In this video, we will explore the sliding filament model. This model delves into the movement of myosin filaments against actin filaments, which is a process known as the power stroke for muscle contraction. This process is regulated by ATP and intracellular calcium. Intracellular calcium plays an important role. Troponin and tropomyosin function to block off the binding sites for myosin on the actin filament, forming a troponin-tropomyosin complex. For the myosin filament to be able to bind to the actin filament, a calcium ion must be bound to the troponin. When a calcium ion binds to troponin, troponin changes shape. The change in troponin shape causes the troponin-tropomyosin complex to move, exposing the myosin binding site on the actin filament. This allows myosin heads to be able to bind to the active binding sites on the actin filament. Here we have a thin filament known as actin and a thick filament known as myosin. ATP is the only energy source used directly for muscle contraction. The powering of these muscle filaments is initiated by the binding of an ATP molecule to a myosin head. This causes the dissociation of myosin from actin. The hydrolysis of the bound ATP into ADP and inorganic phosphate causes a conformational change in the myosin head, which shifts and pivots its position onto a new actin subunit. The ADP and inorganic phosphate bound myosin then binds again to actin. When ADP and inorganic phosphate is released from the myosin head, it undergoes another conformational change that generates the power stroke. This creates a pulling force on the actin filament. After ADP and inorganic phosphate is released, the myosin head is then free to bind to another ATP molecule to repeat the cycle of the sliding movement.